Shadow FX Productions presents Outtakes.
Version 1.0.
It begins in the high Andes and rakes the land all the way to the sea. Some call it Les Gobadillas, the broom of God. It is an endless, punishing wind that defines this place and all who dwell within it. This is Patagonia, the last great wilderness of its kind. At its crown tip, Tierra del Fuego, the land of fire. The broom of God. Players face a constant struggle. spring, glacial melt surges down the mountains and feeds tempestuous lakes. The volatile waters match the fury of the shores. The broom of God. The broom of God. The broom of God. The broom of God. Some call it l'escoba de Dios. The broom of God. It is an endless, punishing wind that defines this place and all who dwell within it. This is Patagonia, the last great room of God's kind.
A comet is like a litter bug. It has a tremendously long tail containing debris of ice crystals and rock and dust. And as the Earth goes through this trail of debris, we see literally hundreds of shooting stars throughout the night sky.
A few times each year, something big lights up the sky. Something solid called bolides. These objects enter Earth's thick atmosphere at roughly 10 times the speed of a rifle bullet. In 2004, David Bowie, asteroid 2004 MN4 co-discoverer, was given the honor of naming it. He named it Apophis, the Greek name of an Egyptian god Apep, the destroyer. If Apophis hits the Earth, it will live up to its namesake. Apophis finds in the sky. A giant asteroid.
Twisted like ribbons. This was your name.
Quarter of a mile scale would have far-reaching implications.
Say,
Upon the signs in the sky,
and no one to turn to,
even as we sort out these questions,
but
upon the signs in the
neither
sky, just out of sight.
don't have a thing to hide.
Even
We
as
all
we sort
know
out
you're
these questions,
bent
upon the
on
signs in the sky, just out of sight.
entertainment.
Even as we sort out these questions, upon the signs in the sky.
Initiating shutdown sequence.
Even as we sort out these questions, upon the signs in the sky, just out of sight.
Initiating shutdown sequence.
Even as we sort out these questions, upon the signs in the
Initiating
sky,
shutdown
just out of
sequence.
sight. They are anything but. Our solar system is a dangerous place. Case in point, our nearest celestial companion is a crime scene spattered with evidence of violent impacts from the past. When we look up at the moon in the night sky, it's a reassuring presence. It lights our nights, pulls our ocean's tides, and marks our days with its faces. But the craters on the moon are anything but reassuring. Like the scars on a prize fighter's face, they have a long and violent story to tell us about epic battles in our neighborhood.
density differs from the Earth's. It shares Earth's chemical makeup. In particular, the variations of elements known as isotopes that were found on the Moon were identical to those on Earth.
Each part of the solar system has its own isotope composition. You look at the Moon, it's bright,
beautifully fit the idea that moon material really was part of the Earth material originally. So, the moon has a similar composition, yet a different density. Hartman and Davis suggested that this similar yet different scenario resulted from an impactor-Earth collision that gave birth to a moon composed partially of pieces of Earth's mantle.
If you hit the Earth with something big enough, you could blow a lot of the crustal and mantle rocky material off the outer part of the Earth. Here's a nice little iron core in the middle, and here's the rocky part around it. You know, hit that, you blow off all this rocky material, big cloud of debris around the Earth. And the moon forms out of that cloud, then you get a moon that looks like what we've actually got today.
A good theory, but what it needed was backup. Feed the data into the model, and you peer back in time to a much different Earth, rotating once every 4 hours in the opposite direction, before it's hit with a glancing blow by a slow-moving impactor roughly the size of Mars. When the impactor struck, its angle, size, and speed all conspired to reset the Earth's spin. The fact that it was a slow-speed collision was a lucky break for the Earth. established that impact craters have distinct features. These features can be replicated by firing a bullet into sand. Shoemaker's work established that impact craters have distinct features. These features can be replicated by firing a bullet into sand. He trained the Apollo astronauts to take samples that would test his theory.
Make them take their rock hammers out and walk around and actually understand the geology of the Earth, so that when they went to the moon, they'd be able to think a little bit like geologists.
shapes the nature of the cosmos that we live in, but it's also the occasional violent collisions between two galaxies, between two black holes, between two stars.
In order for something to have gone right in our universe, things had to go very wrong.
How do we know of these violent collisions, and what do they mean for us here on Earth? Technology allows us to witness destruction beyond our wildest dreams, and to learn what these impacts do to the universe. Parallel destruction. Stars collide, planets are shattered, all life forms are annihilated. But is this really what happens when galaxies collide? To begin to understand what a galactic collision means, we first have to understand the size and composition of a galaxy. A collection of gas, dust, planets, and stars. Lots of stars.
Galaxy is like a city of stars. It's a collection of 100 billion stars that sticks together for billions of years. It's held together by its individual.
A light year is simply the distance that light can travel in a year. Light travels at incredible speeds, 300,000 kilometers a second. And if you multiply that by the number of seconds in a year, you get about 10 trillion kilometers. So the distances in astronomy are so huge that we actually have to use light years in order to measure the distances just between stars. Another way of looking at this is that a beam of light traveling 186,000 miles per second would still take 100,000 years to travel from one end of our galaxy to the other. In the sun's 4.5 billion years of life, it has orbited the center of the Milky Way.
Astronomers owe these galaxy classifications to Edwin Hubble, the namesake for one of NASA's great observatories, the Hubble Space Telescope. Edwin Hubble. He took on the astronomical task of categorizing galaxies. The namesake for one of NASA's great observatories, the Hubble Space Telescope.
one color. At one color.
Pitch black getting wicked. Unidrama get wicked. Pitch black getting wicked. Sunshine sound system on the remix.
It seems blue stragglers had discovered a stellar fountain of youth. Scientists wondered how that could be possible. NASA's Hubble Space Telescope, launched into orbit in 1990, played a key role in answering that question.
Hubble's resolution is so fantastic. If you look with it
Pitch
from New
black,
York to
let's take it back.
you will see two
Downtown,
fireflies.
pick up the
This is
slack.
Hubble.
So charged, they keep it fat. Pete Diggity, coming on contact, gifted massive. Got out back. Overstayers, they lead the pack. My man Shan dedicated to the scratch. Shapeshifter on the attack. Salmonella, stripping them back to the roots. Share our version. Triple S, Alteror, 2001. We on the map. Sunshine sound system on the sunshine got style. Us strictly rules. Sunshine got style. Us strictly rules. Sunshine got style. Us strictly rules. sunshine got style.
Counting all the stars across the heavens, counting all the fishes in the sea. If I try to stop, I'll slide off this rock, then the world will stop, I believe. Climb the wall that keeps me in your garden. Climb along red ladder to the moon. Never reach the top, 'cause the world will stop. But I'm looking up, I believe.
The VLA's ability to detect radio waves allows it to better penetrate the stellar debris.
The radio telescopes and infrared telescopes are really the only way to study that. Just like a visible light telescope is collecting light waves to make an image, we're collecting radio waves to make an image.
Optical and short wavelength radio cannot see into the inner parts of these regions. Radio can. And radio astronomers of long wavelengths such as this facility peer into the inner parts of these regions that are obscured to other wavebands.
Most galaxies have supermassive black holes at their center. They can be 1 million to 1 billion times the mass of our Sun. Despite their mass, we initially couldn't see black holes. So how did we eventually know they were there?
Never reach the top, 'cause the world will stop. If I try to stop, I'll slide off this rock. Never reach the top, then the world will stop. If I try to stop.
Later in the 1970s, we were all startled to find that this optical star, so massive, was orbiting the X-rays at a very high velocity. This high velocity means the X-ray source is more massive than 3 times the mass of our Sun. This essentially established to be a black hole.
Probably the biggest clue to the study of black holes. what's occurring in the Death Star galaxy.
So Chandra allowed us to see the central black hole sources. It allowed us to determine the presence of this X-ray jet. And it's this jet that gave rise to the name of the Death Star galaxy, because the jet points directly in the direction of the companion galaxy, and you can actually see the effects of that radiated beam of energy and particles as it hits the neighbor.
Counting all the stars across the heavens, counting all the fishes in the sea. If I try to stop, I'll slide off this rock, then the world will stop, I believe. Climb the wall that keeps me in your garden. Climb a long red ladder to the moon. Never reach the top, 'cause the world will stop. But I'm looking up, I believe.
We're going this non-bomb box. So we better take a longer legs. It's easy to get lost in this.
In all galaxies sends out far away from us, will recede away from us and disappear from the view in a finite amount of time. The only exception is the Andromeda galaxy, nearest neighbor of our sister galaxy.
Andromeda and Milky Way, their gravity has actually, at some point in the past, reversed any receding velocity between the two of them, and they're now approaching one another because of gravitational attraction.
We're actually on a collision course. Seem to be coming straight at each other. It's pretty bad for us. The Andromeda galaxy, within about 5 billion years, will collide with the Milky Way galaxy.
But what's the evidence of this coming collision? It turns out that the light signatures that Andromeda gives off are the strongest evidence of its approach.
So some stuff are highly colorful. Look for a particular color, it's coming from iron or oxygen or sulfur or something. And you know what color it should be, and you can see what color it seems to be, bluer or redder. If it's bluer, it's probably because it's coming straight after you. And if it's redder, it's going further away. You look at Andromeda, it's blue shifted, and the speed at which that's been moving is 200 kilometers per second. It's coming up fast.
But wait, a collision that destroys life on Earth is only one possible scenario, and not at all the most likely one. So what will actually happen in 2 billion years when these two galaxies begin to approach each other? Because galaxies are incredibly massive, and the distances between them so great, a collision takes billions of years from start to finish. As a result, astronomers can only observe snapshots in the sky. To understand the whole process, they rely on simulations.
Every snapshot we get of a galaxy collision in the universe is really just one piece of a very long sequence. And so these simulations allow you to piece together various situations and see how it develops from approach to passing by to tidal tails to smashing together to mixing.
shamans are really worried that you might make the spirits angry when you start digging.
Going, there's not a lot of oxygen. Country's so sparse, I bet the buzzards have to carry their lunch.
Neighbor Andromeda will collide. But will this collision be a source of creation or destruction?
distant future, our galaxy, the Milky Way, and its neighbor Andromeda collide. But will this collision be a source of creation or destruction? In the distant future, our galaxy, the Milky Way, and its neighbor Andromeda will collide. But will this collision be a source of creation or destruction?
In the distant future, our galaxy, the Milky Way, and its neighbor Andromeda will collide. But will this collision be a source of creation or destruction? The Milky Way and its neighbor Andromeda.